Hey guys, Dr. Brown here, coming to you from Tarlac City, Philippines, and tonight we're discussing the 9 rules for differentiation. And we talked about those last time in the last video. I still have them up here. And we're going to walk through problems actually relative to each one. I don't know, how 1, 2, 3, maybe 8 or 9 problems. And just put the problem up, try to take the derivative, but look at the respective rule that allows us to solve that problem. So we have one here. Y equals x over x plus 3. Now we see that's a quotient. We have a quotient rule. It says I'm going to take, if I take the derivative of f of x, we'll call this top one the f of x, the bottom one the g of x. It says I'm going to take the bottom function times the derivative of the top function minus the top function minus the top function times the derivative of the bottom one, all over the bottom one squared. Okay, so I would encourage you, before you do anything, is write that number down. X plus 3, right, g of x squared, okay? All right, because I usually forget it. That's my kryptonite with this method. All right, so it says take the bottom function, so we have x plus 3 times the derivative of the top function. What is the derivative of x? If we use the simple power rule, this one right here says x to the n, bring the n down, times x to the n minus 1. So what do I have here? I have x, okay, to the first power. I'm going to take that first power and bring it here. 1 times x to the 1 minus 1, which is 1 times x to the 0. Okay, what's any number raised to the 0 power? 1. So the simple answer to this is just 1. All right, so I have g of x times the derivative of f of x plus x, so I have f of x times the derivative of the one on the bottom. So now I have x plus 3. I have the sum rule of derivatives. I can take the derivative of this plus the derivative of that. Sum difference rule. So I have the derivative of f of x plus g of x. Well, this is not g of x here, but you get the idea. 2 different functions, but I can take the derivative of each one, just add them together. So the derivative of x is 1 plus the derivative of a constant, which is my derivative of a constant rule, is 0. Isn't it amazing how many rules we went through just to get to this point? Okay, so derivative of x plus 3 was just 1. So what do I have? Y prime. Oh, I'm sorry. In the quotient rule, that's a negative. Sorry. Product rule is positive. So g of x times the derivative of f of x minus f of x times the derivative of g of x, all over g of x squared. I even have it written down and did it incorrectly. That's why we have to practice. Okay. All right, before I forget it, x plus 3 squared. So now if I distribute the 1 through that, it just gives me x plus 3 minus x. X is cancel. So y prime equals 3 over x plus 3 squared. A lot of different rules there in the quotient rule. Now, we could have worked through this as a product rule using the chain rule. Whoa, what do you think about that? If I take this x plus 3 to the first power, bring it to the numerator, y equals x times x plus 3 to the negative 1. I just brought it up. Okay? Now then, the product rule. It says I can take f of x times g of x, okay, if I'm trying to take the derivative of that, and that ends up being the first one times the derivative of the second one plus the second one times the derivative of the first one. But in order to take the derivative of this, I have to use the chain rule. All right, so let's do this. Y prime, first one times the derivative of the second one. So I've got the simple power rule. I could use the chain rule, if you will, but it's the chain rule. So I'm going to take the -1, bring it down. Have -1 times x plus 3 to the -1 minus 1, which is now -2, times the derivative, this is where the chain rule comes in, times the derivative on what's on the inside. Remember, I'm taking the outside function, taking the derivative of that, and then take the derivative of the inside function, and the derivative of x plus 3 is just 1. The derivative of this one, this is the sum rule again, the derivative of x is 1 plus derivative of a constant. Constant rule is 0. So 1 plus 0 gives me 1. All right, so what do we have here? That should be a plus in there. Dang, Stevie. Oh, no. First one times derivative of the second one plus, I haven't even got to the second part, plus the second one, x plus 3 to the -1 times the derivative of the first one, which is just 1. All right. First one times the derivative of the second one plus the second one times the derivative of the first one. So what do we have here? I have a 1 times -1, which is -1 times x, which is -x, over x plus 3 squared. It was to the -2 in the numerator. Bring it back down, it becomes positive, plus 1 over x plus 3 to the first power, because it was -1 in the numerator. So I brought it back down. Well, I need to be able to add these together. So I need to multiply. I have one of the x plus 3's here, but I need 2 of them. So I need to multiply this by x plus 3 over x plus 3. Okay. So now I have a common denominator of x plus 3 squared. And I have minus x plus 1 times x is x, 1 times 3, I'm distributing the 1, whatever that number is there, plus 3 inside. The x is cancel, and I end up with 3 over x plus 3 squared. Okay. I have something popped up on my screen here, and that's an ugly 2. So we end up with the same answer as before. So sometimes it's a little bit simpler to just not perform the quotient rule, get into the product rule if you can, if it looks to be easier. All right, that's 2 down. Let's take a simple one here. 2x cubed plus 6x squared minus 1. So y equals that. And we're trying to find y prime. So now, what are the rules? We have the sum difference of some things here. So I know that I can, if I'm trying to take the derivative of all of that, I can take the derivative of individual pieces and add or subtract them together, okay? So I know I can do that. So let's take this first piece. What's the derivative of 2x cubed? Bring the 3 down, so that's 3 times 2, x to the 3 minus 1. Plus, bring the 2 down, 2 times 6, x to the 2 minus 1. Minus the derivative of a constant is 0. So we just used the simple power rule. We used the derivative of a constant rule to get this term. So now what do we end up with? Y prime is 6x squared plus 12x, 2 minus 1, x to the first power, plus 0. So y prime, 6x squared plus 12x. Several rules in that one. Okay. Pause any time that you need to look at some more of these. All right, what if y equals pi cosine t, let's say? Well, pi is a constant. So now I have a constant multiple rule. So if I'm trying to take the derivative, I can pull that constant out. And I can then say, well, it's pi times the derivative of cosine t. What is the derivative of cosine? Okay, the derivative of cosine is minus sine. So I end up with y prime equals minus sine t. Minus pi sine t. What if though? What if that were a 2t? Uh-oh. Still use the constant multiple rule. I can pull the pi out, derivative with respect to t of cosine 2t. Now I need to utilize a chain rule. I'm going to let u equal 2t. du equals 2 dt. Okay, well, forget the dt for just a minute. Derivative of this is 2 dt. Well, the chain rule just kind of keeps going, but when you're first learning it, we'll stop at that point. All right, so what does that mean? If you look at the chain general, actually it's a general power rule. It's a little bit, the chain rule. So we're looking at the outside function, derivative of that one, and then the derivative of the inside function. I'll just pull that off here. We're going to keep our constant multiple rule, keep the pi to the outside. What's the derivative of cosine u? I'll go back to that. We'll let u equal 2t. Okay, I'm going to substitute for that. And now I'm trying to take the derivative of this thing with respect to u. Well, the derivative of cosine, we looked at it earlier, is minus sine. So I would have minus sine u, but then what's the derivative of u with respect to t? du equals 2. So I would have sine u, we'll call it u prime. So minus pi sine u times 2 would be my answer. So I end up with minus 2 pi sine u, which was 2t. And that's how those get a little bit more complicated. Look at the outside function, derivative of this would be negative sine 2t times derivative of the inside, which is 2 dt. So minus 2 pi sine 2t. We'll work another one or two like this that might be a little bit easier to understand. Well, the first time I heard chain rule and tried to get comfortable using it, I thought the teacher had lost his mind. All right, What if y equals 7 plus sine x? Y prime, we have the derivative of a constant is 0. The derivative of sine is cosine. Derivative of sine x is cosine x. So 0 plus cosine x, or just cosine x. Okay, so we're using derivative of trig functions. In this one, derivative of a constant. Let's see. Y equals 1 over x minus 3 sine x. Now you remember the algebra rule for exponents. A to the m divided by a to the n is a to the m minus n. You also remember the rule says a to the 0 equals what? Equals 1. Any number, and a can be any number. Any number, if I have 1,000,000 to the 0th power, it's 1. If I have 10 to the 0 power, it's 1. Doesn't matter. X to the 0 power is 1. So I can think about this 1. Rewriting this is x to the 0 divided by x to the 1 minus 3 sine x. So what does that mean? Y equals x to the 0 minus 1. I have that situation right there. Minus 3 sine x. Okay. So x to the 0 minus 1 means I have y equals x to the negative 1 minus 3 sine x. All right, let's use the simple power rule here. I'm going to take the derivative. Y prime equals, bring down the negative 1 x to the negative 1 minus 1 minus, now the constant multiple rule. I'm going to take the 3, now the derivative of sine x. I'll pull the 3 out. The derivative of sine is cosine x. Okay, so I have a negative 1 over negative 1 minus 1's x squared, x to the negative 2, and I'll move it back down, minus 3 cosine x. Okay, get comfortable with your exponents, because this will happen to you a lot. And feel free, pause and walk through this and then come back in. Hey, I'll be here. I keep having these scans pop up on my screen. I certainly hope that's not in the video, or we're doing a virus scan. Okay, what about y equals 8x plus 3 over x squared? Same scenario here. I need to bring that to the numerator. 8x plus 3x to the negative 2. Bring it up. Now y prime. 8 times the derivative, it's constant multiple rule. I'm pulling that constant out. Time I have x to the first power. Bring the 1 down. 1 times 8x to the 1 minus 1. Minus, I'll put the plus. Now negative 2 times 3 x to the negative 2 minus 1. That's my situation here. So I have 8x to the 1 minus 1. So 8 to x to the 0. X to the 0 is 1. 1 times 8 is 8. That makes sense. Okay. Minus 6. Negative 2 minus 1 minus a positive is same as plus a negative. So 6x to the negative 3. And that equals 8 minus 6 over x cubed. Okay. That's y prime. right, not too many more, maybe 3 or 4 more. Just find problems all over the internet, any old books, and work them. I have several manuals full of problems. All right, y equals 7x plus 2. Oh, here we go. Squared minus 3 sine 2x. Whoa, all right, so before we get too carried away, that's my outside function. That's my inside function when we get ready to do the chain rule. Okay, this one, why don't we do something like, let's let u equal 7x plus 2. Okay. All right, let's take the derivative. Well, let's rewrite the equation first. Y equals u squared minus 3 sine 2x. Outside function, inside function. All right, y prime. Nothing to it, right? Bring the 2 down. U to the 2 minus 1, which is 1, times what? U prime, the derivative of u. That's the chain rule. Okay? Minus constant multiple rule here. I can pull the 3 out of this. And now the chain rule on sine 2x. The derivative, let's let t equals 2x. So now I have sine t outside function, inside function. What's the derivative of sine? Cosine. So I'll just do this one side. 3 times cosine t, but t is 2x, times the derivative of what's inside. What's derivative of t? dt equals 2 dx. So it equals 2. So I'll put the 2 here, times 2, so that's minus 6 cosine 2x. What about the other side? That equals 2 times u. U was 7x plus 2 to the first power, times u prime, which was 7. I take the derivative of what's on the inside. Derivative of 7x is 7. Derivative of a constant is 0. So now all of this, 7 times 2 is 14. 7x plus 2 minus 6 cosine 2x. And that would be y prime, the derivative of that equation up here. Chain rule, trig function rule, and again we were using the chain rule on the trig function. Derivative of the outside times the derivative of what's on the inside. Okay? I hope these help. I've gotten a lot of feedback from some people about the rules. They help, and so I just wanted to work through more problems for you. Okay, 4x cubed. So y equals 4x cubed minus 2x plus 5 over x. Now, simplify is always a good thing to do. Since I have one term in the denominator, I can divide each term by that. So in effect, I have 4x cubed divided by x minus 2x divided by x minus 5 over x. That's y. So x cubed divided by x, and this may sound silly, but it's x times x divided by x. Gives me x times x is what's remaining, which is x squared. Now, Okay, go back to that a to the m divided by a to the n, a to the m minus n, 3 minus 1 is 2. So I have 4x squared minus, that cancels, 2 minus 5x to the negative 1. We'll just bring that up. Okay, remember that's x to the 0 minus 1. There's an imaginary 1 sitting out here, and we're calling that x to the 0. All right, so that's y. We've simplified it. Now then, the sum difference rule says I'm taking the derivative of all of these differences, but I can take the derivative of individual ones. Okay, so y prime equals the derivative of this one. So I have 4x, bring the 2 down, 2 times 4, x to the 2 minus 1. Minus, derivative of a constant is 0. So minus 0, minus, now bring down the negative 1 times 5, x to the negative 1 minus 1. So what does this give me here? 2 times 4 is 8. X to the 2 minus 1, that's just x to the first power, minus 0 plus 5. Negative 1 minus 1 is x to the negative 2, and we'll just put it down here. Okay, 8x minus 5 over x squared would be the derivative of that equation. Now we could, I'm not going to do it, but we could just use the quotient rule. Okay. Well, why not? You want to do it? Let's do it. All right. Okay. All right, so y prime, we're going to call this top one f of x, the bottom one g of x. And what does this thing say? It says take g of x, put it in the denominator and square it. Whatever's on the bottom, you're going to square it. Now then, we're going to take g of x, what's on the bottom, times the derivative of what's on the top. So that's, bring the 3 down, 3 times 4 is 12, x to the 3 minus 1, which would be 2. Minus, that's x to the first, bring that down, x to the 0, which is 1. So 1 times 2 is 2. Plus derivative of a constant is 0. So we have 12x squared minus 2 is the derivative of the top one. Minus, and this is where I messed up earlier, I put plus. The top function, which is, and I would encourage you to work with your parentheses here, 4x cubed minus 2x plus 5 times the derivative of what's on the bottom, which is just 1. So y prime equals, I'll distribute the x inside. So x times 12x squared gives me 12x cubed minus 2x minus, I'm going to distribute this negative to the inside, minus 4x cubed, negative negative is positive, plus 2x minus 5, okay, all over x squared. Okay, this 1 obviously just, if I distributed that in, everything's the same. Okay, y prime equals, let's collect our terms, 12x cubed minus 4x cubed, 8x cubed, negative 2x and a positive 2x, those cancel, 8x cubed minus 5 over x squared. Okay, remember, since I have one term on the bottom, that's 8x cubed divided by x squared minus 5 over x squared. What does that give me? 8x minus 5 over x squared, which is exactly what we had earlier. It was just easier to simplify and use the product rule, at least I thought so, than doing all the division. Okay. All right, let's do one more. Y equals 4x plus 1 squared. And we're trying to take the derivative of that. Well, we could say u equals 4x plus 1. Derivative of u is 4, right? 4 dx. Derivative of 4x, 1, bring the 1 down, then, well, let's just do that. That's 4x to the 1, bring the 1 down, so that's 1 times 4x to the 1 minus 1. Derivative of a constant is 0, so x to the 0 is 1. 1 times 4 times 1 equals 4. All right, so we now have y equals u squared. Greatly simplifies it. If you get hung up on that, try to figure out what u might be and simplify. Now y prime is, bring the 2 down. 2 times u to the 2 minus 1 times u prime. So 2 u to the first power times u prime, derivative of u. All right, let's plug in fill in the blanks here. That equals 2 u, which is 4x plus 1. 2 minus 1 is to the first power, times the derivative of u, which was 4. 4 times 2 is 8. So now we have 8 times 4x plus 1 would be the derivative of 4x plus 1 squared. So if you want to distribute that, it's 32x plus 8. All right, so this, I think that was my last problem. I tried to give a splattering of the different rules and how to use them, some tools. You know, the chain rule, general power rule, which I guess we used right here. Yeah, we actually did. Which is just a deeper dive of the simple power rule using the chain rule. That's the only difference there. So, all right, keep working problems, guys. Why are we doing this? We're not crazy. We're trying to build a better tomorrow and do that through math, okay? If there's any, just comment me in the video feedback if there's any problems or specific area that we can help you with, and we'll try to address that. So that's all for now. Keep studying, and we'll talk to you next time. Thanks.